Okay, today we're going to be multiplying polynomials by monomials. Last time we multiplied monomials, right? Now it's a little bit different. Now we're going to be multiplying polynomials by monomials, okay? To multiply polynomials by monomials, you're going to need this property. Anybody know which property we're going to need? So for example, if I have binomial times a monomial, you're going to need this property. Like 2x plus 3 times like 3x. In order to do that, you're going to need this property. Anybody know what property we will need? Starts with D. Yes. Distributive property is correct. And the reason why we say, and of course all the rules that we learn, how many rules have we learned with the polynomials? 3. Do you know when? So the first rule was you add the exponents, remember? Second was when you multiply the exponents, and then third was when you sort of distribute that exponent, right? So with the distributive property and those 3 rules we learned, we can now multiply polynomials by monomials. Okay. So here's what I mean by this. First of all, take a look at this very simple example. Do you see my monomial y? And do you see my binomial x minus 2? So now we could use distributive property and then the rules that we learned to multiply these things together. Does that make sense? When do you only distribute? If you have more than one term. If you have monomial inside, do you distribute, guys? No, that'll be wrong. Only time you distribute is if you have more than one term. That's why it says multiplying polynomials by monomials, okay? Does that make sense? When you have a monomial times a term that's more than one term, okay, then that's when you distribute. Because you wouldn't distribute if inside we had 2x, would you? That would be wrong, right? Only time you distribute is if you have more than one term. But you may say, wait a minute, this says subtraction. I thought that, didn't I tell you that the terms are separated by an addition sign? So how should we rewrite this? All right, Serena. That's right. So you need to rewrite this using the definition of subtraction this way. Y times x plus negative 2 this way. Do you see that? Okay. Then of course you distribute. Right, Rania? Tell me what to write.
Yx plus negative 2y.
Exactly right. And I actually wrote down the step where you multiply these in your head. Can you write these steps out? Okay. Because for something like this, really simple one, you could just do it. But of course, is it going to be always this simple? No. So whenever you distribute, can you write it out? So that, and then don't do everything in your head because that's how you make silly mistakes. And then you could write, and then you can multiply. After you write down this step where you multiply these terms together. Is that okay? And again, how many terms do we need inside here? You must have, if you're going to multiply a monomial times binomial, must have how many terms? Must have, to use distributive property, must have what? More than how many terms? One term. Please keep this in mind. Okay, people try to distribute if you have monomial inside. That'll be wrong, okay? Only time you distribute is if you have more than one term. Does that make sense? Right? You either have a binomial, trinomial, or whatever many terms. Do you understand what I'm saying? If you have monomial in there, that'll be wrong, okay? So you must have one term, more than one term. Oops, that's it. Must have more than one term. Okay, cannot have binomial in there. Okay, may I go to example 2 then? Yes? Okay. So take a look at example 2. Could we distribute in this example? I have monomial negative 3x times parentheses 2x squared plus 4x minus 1. Could we distribute in this case, guys? Yes. Addison, why not? Oh, okay, so we can't distribute, right? Why? Because look at how many terms do we have inside? We have more than one. We have 3 terms. So we should distribute now. Does that make sense? So before you distribute, you should always check and see if you have more than one term. You understand? If you just have one term, you can't distribute. That'd be wrong. You know what I mean? You just multiply them. That's monomial times monomial. Okay? And do you think it's a good idea to change that minus 1 as an addition? So I'm going to rewrite it this way. And I wrote x to the first, 4x to the first to remind you that there is an invisible 1 as an exponent, right? Go ahead, everybody try to multiply. Let's see whether we get the same answer. Go ahead, everybody try. let's see. Who could tell me how to write this? I'm going to, let me pick somebody at random. How about, listen, what should I write? So, yeah, I don't want you to write the whole thing. I just want you to tell me, you know how I told you in previous step how you just wrote down before you multiply the whole thing together? So, what do I get? First, I get negative 3x. Good. Exactly. And notice between each of the terms, right? There is what symbol? What kind of symbol do you see? Yes, an addition symbol. Isn't this nice? Once we change everything to addition, it's really easy to see, right? That between all the terms, right, we have addition in there, so you don't have to get confused or anything. Okay, so then, did you all write this step down? I want to see this work, okay? This is the kind of work I want to see on your homework tonight. Everybody clear with this? Yes? I know that some of you could just do this in your head, right? But I want you to actually write it out. Okay, so if you didn't, go ahead and write it out now. Okay. All right. Who could tell me then? Okay, some of you are still writing. Let me wait. Okay. Go ahead. Write. I want this step. Okay, because I'm telling you guys, this is where people make like silly mistakes because they try to do too much in their head. Okay. I want you to write it out like this. Okay. I'll wait. So then, Amy, what did you get when you multiply these things out? So first term becomes negative 6x cubed. How many people agree? Negative 6x cubed. Very good. Even though there isn't any exponent here, this is x to the what power, guys? Negative 3x to the 1 first power. So that's why we add the exponent, right? 1 plus 2 is 3. That's why we get x to the third. Okay, next. Plus negative 12x squared plus 3x is exactly right. So do you see how we get this? And of course, look at the middle term. It's plus negative 12x squared. So using the definition of subtraction at the very end, when you write down the answer, you should just simplify. And then you should write it like this. How many people have the answer? The answer comes out to be. How about Angie? Yeah, tell me what to write at the very end. As we simplify this expression, when you write the answer, instead of writing plus negative 12x squared, what should you write? Using the definition of subtraction, we should write this as. Right, so just write negative 12x squared. Does that make sense? Right? Instead of writing plus negative. Any question? Does that make sense? Are we good? Okay. So maybe I should write, some of you haven't, maybe I should write down that exponent. What's, again, the exponent for this x is really, there's invisible, 1, and then what's the exponent for this x? Negative 3x to the first, and then 4x to the first. That's how you get second power, right? X to the first times x to the first, you add 1 plus 1. Isn't that how you get 2? Right? And here, x to the first times x to the second power, right? Isn't that how you get x to the third power? Right? Does that make sense? So guys, write out the exponents if you're multiplying these. Because if you don't see any exponents, people forget that, and then they write the wrong answer. All right, may I go to example 3 now? Yeah. You okay? All right. Okay, why don't you? I forgot to circle the answers. I just did. Okay. Example 3. Why don't you do this yourself? It says 4x squared times in parentheses 5x squared minus 2xy plus y squared. Do you think I want to see that work? Where you change it to addition and then how you multiply, right? Don't do it in your head. Does that make sense? I'm telling you, that's when you make silly mistakes. Because especially those exponents, right? People, okay, so please take your time to write out all these steps. This is how you show work, okay? I'll wait for you. And of course, feel free to ask your groups and so forth. That's fine. Who could tell me, first of all, what to write? Let's change it to addition. How about Rania? Tell me what to write in the example 3. Let's write it as an addition. What do I write here?
4x squared minus 5x squared plus negative 2xy plus y.
Exactly right. Very good. And I even wrote x to the first, y to the first, so that I don't forget, right, to add the exponents. Okay. So then, Audrey, can you tell me what to write next?
So then you multiply it all.
Right.
So you do,
But I want you to write out that step, right? I don't want you to do that in your head. Okay. So.
4x to the power 2 times 5x to the power 2
Good.
plus 4x to the power 2
Mm-hmm.
and then in parentheses negative 2
Mm-hmm.
and then xy
Mm-hmm.
and then plus 4x squared times y to the
Exactly. How many times do we need to distribute this monomial to this polynomial? 3 times, because Rania, how many terms do you have? You have 3 terms, right? That's Ria. I'm sorry, Ria. We have 3 terms, therefore we need to multiply that monomial by 3 times. Does that make sense? If you have 5 terms, how many times would you have to multiply that monomial by? 5 times. Does that make sense? Anyway, so Audrey said it correctly. Now, Ria, tell me what to write.
Then you multiply, so then you get 20x.
Right. To the
Fourth
4th power, because you do 2 plus 2, right? Yeah, plus
negative in parentheses plus negative 8x cubed y
good 8x cubed, because there's x to the 1st power, right?
plus 4x squared.
Exactly. Very good. So let me write. So how many people got this answer right here? So just like we have said, of course I changed the plus negative as addition minus, right? Subtraction, using the definition of subtraction at the very end. So you get 20x to the 4th minus 8x cubed y plus 4x squared y squared. Eric, did you get that? Raise your hand if you got this. Raise your hand if you didn't. Anybody need any help? Do you see your mistakes if you didn't get that? Yes? Do you see it? You got it? Okay, good. Any questions? This easy? Okay, so this is kind of thing that you'll be doing for your homework tonight. Of course, they get a little bit more creative. Okay? So that's how they get sort of more fun here, okay? Let's take an example 4. So take a look at example 4. This looks kind of interesting. It doesn't look the same as before. Okay, so I got x times, in parentheses, 2x minus 3. And there's another parenthesis in there, 1 minus x. Okay, so it's x times, in parentheses, 2x minus 3 times, in parentheses, 1 minus x. Okay. So what should we do? This one looks a little bit different than all the other ones that we've been doing. I want you to all think about this. So write it down. What should we do first in this example? Anybody? Oh, okay. 1, 2, 3, 4, 5, 6. Okay, another of you. Annie, what do you think?
You distribute the negative 3 into 1 minus 3.
Okay. Jonathan, do you agree? Okay. So I'm going to actually first write everything into addition. Then you're right. I need to, order of operations says you have to deal with what's inside the parentheses first, right? What can you do with things inside the parentheses? You can what? Always simplify, right? Couldn't we distribute that negative 3 within the parentheses first? Right? So that you get some kind of polynomial inside the parentheses first. Does that make sense? So if you have like parentheses inside the parentheses, you should always simplify that inside, right? By distributing it. So can somebody tell me what I get if I do that? How about Jonathan? What do I get here when I distribute that negative 3?
You get x times x, and then in parentheses 2x minus 3 plus 3x.
That's right. And I actually left it as addition. Is that okay? Plus negative 3. All right. Now, how many terms do you see inside the parentheses? Show me with your fingers. How many terms do you see? Good. Okay. So I should multiply that x 3 times, right? Not quite. Always simplify. Look at inside the parentheses. Rania, do you see anything you could simplify? 2x and 3x. Aren't they like terms? So you will still get the right answer if you distribute that x 3 times and then gather the like term at the end. But why not simplify inside here, right, Eric? What do I get when I simplify inside the parentheses? 5x plus negative 3 is exact. Do I get 5x squared? No, I am gathering my like terms. Am I not? So I'm using the distributive property backward. Isn't this like 2 plus 3 times x? So that's how you get 5x, don't you? Then, of course, you distribute. Isn't this a lot simpler? Right, guys? All right, so when I distribute now, James, what should I write? X times 5x, right? Plus x times negative 3 is exactly right. So this is what we get, right? And of course, let's multiply them out. Look, let me actually write out the exponents. This is x to the what power right here? X to the, even though you don't see the exponent, this is x to the first. Here, 5x to the first again, and this is x to the first. Okay, so who could help me here? How about Nicole? Can you tell me what to write?
5x squared
Uh-huh.
plus
You got it. 5x squared plus negative 3x, right? And of course, you could write this as 5x squared minus 3x using the definition of subtraction at the very end, right? When you write the answer, okay, you could just do that. Any question? Do you understand? So, do you think it's important to always simplify if you can? Yeah, it makes it a lot easier, doesn't it? Okay, I mean, you get the same answer at the end, but it just makes it easier when you simplify before you do anything, if you can simplify. Is that okay? All right? Are we good? All right, may I give you the next example? Okay. All right. So sometimes they give you an example, they give it to you vertically to multiply. 2a squared b plus 2ab squared minus ab times negative 2ab. Something like this. You don't really have to do it vertically. People normally don't do it vertically. So is it okay to then rewrite it as horizontally? Yeah. Which one do you think I'm going to write first? The trinomial or the monomial first? Monomial. Okay. So I will just write it this way and then distribute. Is that okay? And as I write, you see how I change it to addition? And I wrote down the invisible exponents too. Do you see what I mean? So if they give it to you vertically, it doesn't matter how you do it. You could just do it horizontally and distribute. Is that okay? Go ahead, everybody try. I'll wait. This should be pretty straightforward. Okay. All right, Indira, tell me what to write, please. I don't know why I circled that negative 2. Anyway, go ahead.
maybe in parentheses negative 2
Uh-huh.
ab then times 2a squared b
Uh-huh.
plus
Uh-huh.
negative 2ab times ab plus
AB or AB squared?
ab squared
AB squared plus
plus negative 2ab in parentheses times
negative AB, correct? Did you all get that? Like this? Yeah? Please do that step. I know that some of you, you could do it in your head. I'm telling you, this is where you make silly mistakes, okay? If you mess up on one little exponent, then you're done, okay? All right, Destiny, tell me what to write. Now, let's multiply them.
then we write you multiply and get negative 4a cubed b squared
Good.
plus negative 2a squared b cubed
Uh-huh.
plus 2a squared b squared.
Did you all get this? Like Destiny said? Negative 4a cubed b squared plus negative 2a squared b cubed plus 2a squared b squared. Do I have any like terms? If I did, I will simplify those, right? I don't have any like terms, do I? What about the first term and the second term? Don't they look sort of similar? Almost, but this is not quite like terms, are they? They don't look exactly alike except for their coefficients, do they? This is x to the third, the other one has x to the second. This is b to the second, this is the x to the third. Okay? So they're not like terms, okay? Even though they made really similar. And of course, plus negative means subtraction, right? By definition of subtraction. So here you go. How many people got this answer? Raise your hand. Negative 4a cubed b squared. Negative 4a cubed b squared minus 2a squared b cubed plus 2a squared b squared. Yeah? Did you guys get this? Any questions? No questions? All right. May I move on to the next example? Oh, okay. I'll give you time. Take a look at this example. I put 2 stars on this. All right, so it says 2x in parentheses 3x squared in parentheses negative 4x in parentheses 2. Okay? I'm sorry?
The one before was example.
Oh, one before was exactly like this, right?
No, it was example 5.
Oh, was it example 5?
Yeah.
Oh, okay.
This is
Example 6 then? Is it? I'm sorry. It should be example 6. Let me fix that. All right, here you go. Sorry. So, I'm gonna give you time. I'm gonna give you time to do this one yourself. Can you do this yourself? Yeah? Yes? Okay, go ahead. Everybody try. Alright, how many people distributed that 2x? That monomial? Raise your hand. Okay? Oh, you guys didn't do that?
we do what not first.
Why don't we distribute that 2x inside the parentheses? Cole? Yeah. Look at inside the parentheses. That whole thing inside the parentheses, is that a polynomial? What is it? It's monomial, isn't it? Right? Isn't this monomial? Right? How many times do we need to multiply 2x to that inside? Once, because there's only one term. Right? This is not a polynomial because look, You have multiplication in between all the terms. These are all factors, aren't they? So what should you do first, guys? Yeah, it looks like it's a trinomial, doesn't it? So you don't put, this is not a trinomial. Look, everything's multiplication. Yes, Alvin?
You just forget about the 2x.
Yeah. Uh-huh. What do you do inside the parentheses? You?
You do 3x squared times 4x times 3x.
Yeah, you just multiply the thing inside. In other words, you simplify inside the parentheses first, right? Because isn't this whole multiplication? Everything is multiplication, right? What do I get when I multiply the whole thing inside, guys? E-Ray? Negative 24x to the third. So I sort of wrote it, separated them out, and you do get negative 24x to the third. Always what? Simplify. Do you see that? Right? How many people realize that? How many people first thought it was a polynomial and then realized it's just a monomial? Okay. Do you understand? Does that make sense? All right, then. What's the answer? What do I do next here? Who haven't I called? I haven't called Max. What do I get?
Negative 48x to the 4th.
Yeah, this is simply negative 48x to the fourth. I even separated the numbers, right? Because everything's multiplication, right? You can multiply in any order she likes. I gather all the numbers and all the variables together. How many people got negative 48x to the fourth? Very good. How many people changed their mind? How many people realized as they were doing this, oh, this is just a monomial? Okay, all right, few of you. How many people just thought, oh, that's just a monomial, just by looking at it? Oh, you guys, okay, very good, right? Please be careful. If you have monomial, right? If you have monomial, then you just multiply it once, okay? Any question? Are we good? May I go to example 7? Yes? All right. Take a look at example 7 here. This one looks very different than all the other examples that we've seen so far. Write down 4 times, write this down, 4 times y minus 1 in parentheses minus 3 times y minus 2 in parentheses equals to 0. How is this example 7 different than all the other examples that we did today? Okay, few of you see it? Tegan, what do you think? What's the difference? In other words, it has the thing that's different than all the other example? Huh? Yeah, what does she mean by this? This is, how is this different? Alet? This is an equation, right? Because you have an expression equal to another expression, which just happens to be 0. That's still an expression. Do you see? All the other examples that we did today were all what? All expressions, right? Now we have an equation. What do we do with equations now? We solve. Okay, so this one, even though it doesn't say anything, right? It should say solve, right? So I did put anything just to, because I wanted to recognize this is an equation. Whereas all the other ones we simplified, isn't that right? Look at all the examples that we've done so far. Example 1 through 6, all we did was we simplified it, right? We didn't solve for any of the variables, did we? Now we're going to solve. Is that okay? So in order to solve this, first, how many subtractions do you see in this example? Show me with your fingers. How many subtractions do you see, guys? Okay, I want 100% participation. How many subtractions do you see? Okay, some of you say 2. There are actually 3. There are 1 each inside the parentheses, but what about that subtraction sign right in the middle? Right, that's a subtraction sign right there. There are 3. Who can tell me how to rewrite this into an addition? How about Elisa? Parentheses. Exactly, equals to 0. Does that make sense, guys? Then, please write everything to addition. This is going to be helpful. Then, how many terms do you have in each of these parentheses? You have 2, right? They're binomials. So you're going to multiply 4 twice with those binomials. Negative 3, you're going to distribute the negative 3 twice. Is that okay? Yes? Go ahead. Everybody try and solve. Oh, wait. So then, what do we do now, guys? We have an equation. One person knows. Let me actually, pick someone at random. How about, who haven't I called today? Daniel. What do you think, sir? What do we do next? We need to do what? Yeah, what kind of work do you, so in other words, what should we do next here? What do we do, first of all, with 4 times y plus negative 1? We distribute. Yeah, exactly. Tell me what to write.
4y
Mm-hmm.
minus 4
Right.
minus 3y plus
Exactly. Equals to
6.
0. Could I forget about that part on the right side? Equals 0 part? No. Then is that an equation? No. You all of a sudden now you just have an expression. So I actually wrote out that step, right? Okay. I just wrote out that step, and then Daniel's right. This is what I get. Would you not agree, guys? All right. Am I done? What should we do next? Stephanie? Combine like terms. Let's see. Who haven't I called today? I haven't called Kyle. Do you have any like terms? Yeah. 4y plus negative 3y are other like terms, aren't they? So what do I write here? How about Thomas? Tell me what to write, please.
After that you add together the 4y and negative 3y.
Exactly. Which you get as
Positive y.
positive y. And what about negative 4 and 6?
It's a positive 2.
Positive 2. So doesn't that equal to 0? I even underlined the like terms there. Right. Alright. Are we done? No? How do we solve for y? How about, I haven't called, let me see. Oh, Allah, what do you think? Subtract 2 from both sides. Or add negative 2. What's the answer? Y is equal to negative 2. Any question? You could either write it this way or the other way. It's up to you. Any questions? Yes, sir. Go up. Okay, we got a question up here. Yes?
You just like add 3y, 3 times y minus 2 to the 0.
Which one are you here? Okay, where are we looking at? First line, second, third, fourth.
To the first one.
First one, the first up here.
Oh yeah, the one all the one where it says 4 times y minus 1 minus 3 times y minus 2. If you just add 3 times y minus 2 to the 0.
Oh, I see. So move over the whole thing to the right side, and then, yeah. But then, don't you want to gather your like terms anyway? You have to gather your like terms anyway. So, right? So on the left, you just simplify the left side, and then you solve. But you could do it that way, and then you still get the right answer. Yeah, you could move that binomial on the other side. But then I think that'd be too much work. Any question on this? Does this make sense? Are we good? Can you do something like this for your homework tonight? Yes? Okay, good.